In this lecture, we're going to walk through another example problem for balancing half reactions. Again, I've placed here, and this is the example that's in your lecture notes, a set of steps to go through to balance your half reaction. We'll always divide it into two half reactions, balance our atoms, balance our oxygen and hydrogen, then balance charge and bring everything back together. And then if it's in basic conditions, we'll adjust by adding hydroxide ions to both sides in the amount of protons that we have. So let's do it. This is actually going to involve chromate again, I realized. But we've got ethanol and chromate combining to form formaldehyde, I think, CH2O, and chromium atoms that are ions. So the first thing that we'll do is we'll go through and assign oxidation states to all of our elements and try to determine which one's being oxidized and which one's being reduced. And we'll see that our carbon in our ethanol has a -2 charge, and then it's a +0 charge in our product. And so that's going to be a loss of electrons that occurs between our reactants and products, and that equals oxidation. So we can write out that oxidation half reaction like this. And so when we balance our half reaction, we're looking for taking just the element that is being oxidized or reduced as our reactant and product, and whatever molecule it's a part of. So we take the whole thing, but we don't take anything more than that. So looking at our chromium metal, we can see that we have a +6 charge in our reactants that becomes a +3 charge. So it's undergoing reduction. It is going to be gaining electrons that it's taking from that carbon atom. And so we can write out that half reaction as just the chromium and becoming chromium ion. And so these are the two reactions that we'll balance separately and then bring together. All right, so let's walk through this. So the first step is to balance each half reaction by mass. And so we're really looking at making sure we have the same number of atoms on both sides of the equation. I'm going to start first with my carbons and make sure the carbons are balanced. And so I've got 1 on both my reactant and product side. Great, done. So then I'm going to go through and balance my oxygen atoms. So I've got 1 on my reactant side and only 1 on my product side. So I don't actually have to balance anything. If I had an imbalance in those oxygen atoms, I would add water to balance it out. So now I balance out with my hydrogens. And I've got a total of 4 hydrogens on my reactant side and 2 on my product side. So if I add 2 H pluses to my product side, that will balance out my hydrogen atoms. All right, now looking at my other reaction, let's look at the chromium side. I need to balance out my chromium atoms. I've got 2 on my reactant and only 1 on my product side, so I place a 2. Then I need to balance out my oxygen atoms. I've got 7 on my reactant side, so I'm going to add 7 water molecules on my product side. And lastly, I'm going to balance out my hydrogens. I have a total of 14 hydrogens on my product side, so I can balance that out with 14 hydrogens that are hydrogen ions. And now I have the atoms, or the mass, of these 2 reactions balanced. Now we're going to balance charge, and looking at this, I want to be really careful to not balance my charge based on the oxidation numbers. I used those to determine if something was being oxidized or reduced, but if I continue to use those to balance my charge, I will get the wrong answer. So this is reduction for methanol on our top part, and if I focus on just the +2 oxidation state of carbon becoming +0, I would be adding 2 electrons to my reactant side to balance out that oxidation state. We're not going to do that, though. Instead, we're going to be looking at the total charge of the equation. And so my total charge is 0 for the methanol. On my reactants, or my product side, I have 0 coming from this formaldehyde. I've got 2 times +1 for a total of +2 coming from these 2 H pluses. So I've got 0 going to +2. I'm going to add 2 electrons to balance out that +2 charge to equal 0. So my product and reactant side are the same. So I write that right here. So now looking at my next equation, again, if I just focus on my oxidation state changes, I'm going to get the wrong answer. I would probably then put +3 electrons on my reactant side. But if we look at the total charge of this instead, we'll see that on our reactant side, we have -2 from our chromate plus 14, which is coming from our 14 H pluses, for a total of +12. And I'm going to compare that to my product side. My water is neutral, and my chromium ion is, there's 2 of them, and they're both +3. So times +3, it's going to be +6. So to balance this out, I really need to reduce that +12 charge. And so I'm going to add 6 electrons to bring it down to +6 instead of +12. Right. Now I'm going to make sure that my electrons are the same in both of my half reactions. And so comparing this, I've got 2 electrons from the methanol reaction, and I've got 6 electrons from the chromium. So to be able to make these balance out so my electrons cancel when I bring these 2 half reactions together, I really need to multiply my top reaction by 3. And I'm going to make sure that that happens to everything. So that 3 is going to multiply against this 2 for 6. It's going to become 6H plus. It's going to become 3 CH2 oxygen, and it's going to become 3 methanol. So I now have 6 electrons on both of my half reactions. So now I can work on summing these together, and I'm just adding these up. So that way all my reactants end up on the same side of my summed equation, and all my products are together as well. And now I can look at this final equation and see if there's anything that I can cancel out. And looking at that, there isn't. So there's nothing to cancel out except the electrons. And so that's my balanced equation. If I were to then make this under basic conditions, what I would do is I would add 8 hydroxides, because I have 8 protons on one side of my equation. And I would do that to both sides, so that way I'm not actually fundamentally changing this reaction. These hydrogens and hydroxides are going to combine to form water. And so this reaction will look like 3 methanol, it's my Cr2O7, plus 8 waters will form my 3 CH2O, 2 chromium ions, my 7 water, and my 8 hydroxide ions. And I can cancel something out now. These 7 waters here can cancel out 7 of the waters on the reactant side, leaving me just 1. And then I have a balanced equation under basic conditions.